Norton's theorem statement, any two terminals of a network can be replaced by an equivalent current source and an equivalent parallel resistance. That means, suppose any network, here it is a network is connected to the terminal A and B to the load resistance RL. So, without considering the load resistance RL, we are replacing whole network with IN, that means Norton's current and the Norton resistance both are in a parallel. So now we will see the steps for solving the Norton's theorem. Firstly, pause the video and just copy the given steps. Now the different steps are, first one is remove the load resistance RL and put short circuit across the terminals. First remember that the steps will not be cleared without considering the problem. So we will explain in detail the steps during solving the problem. So just we are read out the statements or steps. First one is remove the load resistance RL and put a short circuit across the terminals. Second one is find the short circuit current IN or ISC. IN is a Norton current, ISC, or sometimes we are calling it as ISC. It is a short circuit current. Third step is find the resistance Rn as seen from the A and B. That means we are removing this load resistance RL and through the terminals A and B, here we are finding the Norton resistance, and by replacing the voltage sources and the current sources by their internal resistances. So we know that the internal resistance of a voltage source is 0. So we are replacing the voltage source with the short circuit and the current source with open circuit, because the internal resistance of the current source is infinite. The next step is replace the network by a current source IN in parallel with resistance RN. That means like this, IN is in parallel with RN, and by applying the current division rule, we are finding the load current which is flowing through the RL. So if you have to see the current division rule, just watch the previous video for current division rule. You will more clear about the current division rule. So what it is, suppose we have to find the current through the load resistance, that means through this resistance. So the current division rule says in the numerator we are considering the resistance which is in parallel with this. So Rn divided by addition of both, that means Rn plus RL into the total current. Total current here we are considering it is IN, so into IN. So this is the formula. So by using this formula we are finding the IL. This is the final step. So all these steps will be cleared by considering the problem. So we are considering the first example for a Norton theorem. Find the current through a 10 ohm resistance, that means through this 10 ohm resistance. So when the question is for finding the current through the resistance, that resistance will be the load resistance. So this 10 ohm is the load resistance. So we are considering RL is equal to 10 ohm. In that, the first step is calculation of IN. So now see the step. Remove the load resistance RL and put a short circuit across the terminals. So here it is a load resistance, that means 10 ohm is a load resistance. We are removing the load resistance. So we are just removing the load resistance and putting a short circuit between these two terminals. Suppose this terminal is A and this terminal is B, and finding the short circuit current. That short circuit current we are calling it is IN or ISC. So we have to find this current. It is a Norton's current. For solving this problem or for finding a Norton's current, we will solve this equation or a circuit by a mesh analysis. For a mesh analysis, we can also see the previous video for a mesh analysis or a loop analysis, so it will more clear. So here we are considering the two loops. Suppose this is the first loop, this is the second loop, and current through the first loop we are considering it is I1, current through the second loop we are considering it is I2. Now the next step in the mesh analysis is we are giving the sign conventions as per the direction of current. These two currents both are in a clockwise direction. So it is going like this from down to up. So it is in the upward direction. So like this in this direction. So starting terminal we are considering plus, end terminal is minus. Then through this 2 ohm resistor current is flowing like this in the downward direction. So starting terminal we are considering it is plus and the end is minus. Then for the second loop current is flowing like this from this terminal to this terminal. So it is plus to minus. For the 2 ohm resistor it is going upwards. So it is plus to minus. This is the second step. Now the third step we are applying the KVL. We are applying the KVL in the loop 1. So suppose we are considering the 20 volt source first. So the current goes in the upward direction, that means minus to plus. So we are considering here it is a plus 20. Then for the 2 ohm resistor, current is flowing in downward direction. But when we are considering the first loop, we have to subtract the second current from the first. That means I1 minus I2 we are considering, because current through the 2 ohm resistor are I1 and I2 both. So it is from plus to minus. So it is minus 2 into I1 minus I2. Here the I1 considered first because we are considering the first loop. Then for the 5 ohm resistor current is flowing in upwards direction. So it is plus to minus. So we are considering here it is a minus 5 into I1 is equal to 0. So by solving this equation, or we are just simplifying it, so it is a 20 minus 2 I1 plus 2 I2 minus 5 I1 is equal to 0. So final equation is 7 I1 minus 2 I2 is equal to 20. Suppose this is the first equation. Now we will apply the KVL in the second loop. So see here, suppose we are starting from the 8 ohm resistor, current flowing like this in this direction, that means plus to minus. So we are considering it as a minus 8 into I2. For this 12 volt source it is plus to minus, so it is a minus 12. Then for the 2 ohm it is plus to minus, so it is a minus 2. But here we are considering the second loop, so it should be I2 minus I1 is equal to 0. So by solving this or by simplifying this, so minus 8 I2 minus 12 minus 2 I2 plus 2 I1 is equal to 0. So the final equation is 2 I1 minus 10 I2 is equal to 12. So suppose this is second equation. So by solving these two simultaneous equations in a calci, we are getting I1 is 2.667 ampere and the I2 is minus 0.67 minus 0.67 ampere. So see here in this circuit we have to find the Norton's current, and this Norton's current is simply the I2. So we don't need an I1. So this I2 is directly, we are considering it is an Norton's current. So it is minus 0.67 ampere. See here is the current minus. So it will clear from the figure. See here in this figure we consider the direction of current in upward direction, or when we are considering the upwards current it is a positive, and for an downward current we are considering it is a negative. This is simple difference. So we are considering the IN in a downwards direction. Now the next step is calculation of an RN. So here it is IN, it is the final answer for an IN. Then the next step is calculation of an RN. So what is the next step? How we are finding the RN? See here, find the resistance RN as seen from the point A and B by replacing the voltage sources and current sources by their internal resistances. That means we are removing the load resistance. We are this 10 ohm resistance, we are removing the load resistance, and from these two terminals, suppose this is the A terminal and this is the B terminal, from these two terminals we are finding the final resistance. But during finding the resistances we are replacing all the voltage sources and the current sources by their internal resistances. So voltage sources we are replacing it with short circuit and the current source it with open circuit. So here it is a 20 volt source, we are just short circuiting it. Then here it is a 5 ohm resistor, then this 2 ohm resistance as it is, here it is a 2 ohm resistance, then here it is a 8 ohm resistance as it is, and this voltage source will be short circuited. So short circuiting the voltage source, and here it is the terminal A and the terminal B. In the between these two terminals we are finding the Norton's resistance, which is Rn. So see here, for finding the Rn, this 5 ohm and the 2 ohm are in parallel, so simply 5 parallel with 2, and this parallel combination will be in series with 8, so plus 8. So we are just solving it. So parallel combination 5 into 2 divided by 5 plus 2 plus 8, so it is equal to, the final answer is 9.43. so 9.43 ohm, it is a Norton's resistance. See the next step, replace the network by current source IN in parallel with resistance Rn. So we are considering the IN in parallel with Rn, and it is also in parallel with IL. That means the circuit like this, we are replacing the circuit like this. So here the current IN is a negative, so we are considering the downward direction. Now IN is 0.67 ampere, Rn we got it as 9.43 ohm, and the IL is, Rn is 10 ohm. So by using this formula we are finding the IL, that means current through RL. So the direction of IL will be like this. So IN is coming here to this node, going here and going here, so it is in the upward direction. So it is equal to Rn, Rn is 9.43 divided by 9.43 plus RL, RL is 10 ohm, 10 plus IN, IN is into 0.67. So the final answer is IL is equal to 0.33 ampere, which is in the upward direction. So this is the method for finding the current through any load resistance by using a Norton's theorem. Thank you.